Methylene Blue, as I understand, has some MAO activity, can adjust some of the enzymes that in turn adjust levels of serotonin.
Methylene Blue, fascinatingly, is primarily, exclusively a mitochondrial agent. It is an electron acceptor and donor. So that is what Methylene Blue does. It can accept electrons and it can donate electrons. So it's an electron shuttle, if you will. And how does that relate to mitochondria? Mitochondria, as they are producing ATP, electrons are flowing down the electron transport chain. And that is what results in the production of ATP. If it gets shuttled through the uncoupling protein, it results in heat production. And when electrons flow out of that system, when they leak out of that system, it creates reactive oxygen species, which again are very harmful to both mitochondria and cells. So if you have dysfunctional mitochondria that don't seem to be able to contain the electrons appropriately, electrons are leaking out. So these would be mitochondria that are producing more reactive oxygen species than they should. Does that ever happen in biology? 100%. We've got decades of evidence that aging, neurodegeneration, even obesity, type 2 diabetes, and a wide range of neuropsychiatric disorders are associated with that process. The increased levels of reactive oxygen species, often referred to as oxidative stress. So we got decades of evidence strongly supporting that. Can methylene blue play a role in that? Absolutely, because methylene blue can come in and take some of these wayward electrons and prevent them from creating reactive oxygen species, which might help calm things down. One of the challenges with methylene blue, as we discussed before, you can have too little and too much. Same with methylene blue. You can have too little and too much. You don't want to accept too many electrons. These electrons need to be flowing to the places they should be flowing. As opposed to oxidative stress, the polar opposite of that is called reductive stress. And that too has been found in people with schizophrenia and bipolar disorder and some other disorders. So it's really about dysregulated kind of balance between oxidative and reductive stress. And methylene blue, if you take it in overdose, could become a reductive stressor. So you don't want too much, but so we do have pilot trials, again, small, not super well done pilot trials in a wide range of neuropsychiatric disorders. Depression, bipolar disorder, schizophrenia, Alzheimer's disease, others, many of them suggesting a benefit.
Do you know what the dosage range? Methylene blue, as I understand, has some MAO activity, can adjust some of the enzymes that in turn adjust levels of serotonin, which is why I haven't taken it. I've just been cautious about, I don't really want to boost my serotonin. There's this recent study out of a lab at Stanford showing that the rewarding properties of various things, as we know, increase dopamine in anticipation of a reward, but also important, it seems, these are mouse studies, but serotonin drops as dopamine goes up. And that drop in serotonin is at least as important as the increase in dopamine for the reinforcing properties of certain behaviors and substances. I'm very reluctant to tamper with anything that would raise serotonin because in these studies, this difference between dopamine and serotonin seems pretty vital. I mean, that's not to say I'm like terrified of anything that increases serotonin, but to do it pharmacologically just seems a little sketchy, given I don't have a clinical need that I'm, at least not that I'm aware of.
No, well, and that's actually one of the warnings with methylene blue is that if taken in too high of a dose, you can actually get serotonin syndrome.